So what I intend to do is be very brief, introduce our Professor Dr. William Grassi, who's the head of the Villanova Institute, executive director, I should say, and he will introduce our speaker to you. Let me say something about metanaxis, which, since I'm on the board, I have a commercial opportunity here. Our mission is the constructive engagement of religion and science. And we've been doing this for quite a number of years. And we, specifically in the last 10 years, we've been located in the Philadelphia area. We have programs trying to bring together religion and science exponents all over the world. Currently, we operate in 40 countries. We've had a lot of experience working with the John Templeton Foundation and managing and instructing and evaluating these kinds of efforts. And so what I'd like to do just for the moment is to introduce to you the executive director of the Villanova. So we'll tell you a little bit more about our speaker, and that is Dr. William Grassi.
Metanaxis has long been concerned with what is sometimes called the ethic of evolution, the history of nature, the new universe story, also known as big history. And in fact, recently we launched a new website called ourcommonstory.net.com. You can find it, where you'll find lots of resources about big history. In promoting the constructive engagement of religion and science, we're very much concerned that good, rigorous science inform that dialogue. And the most complete vision that we have of contemporary science is this amazing story of the universe, from the Big Bang to the 21st century. There's a number of books that have been published over the years on this topic, but by far the single best book was written by our speaker today in 2004. David Christian wrote Maps of Time, an introduction to big history, which puts it all together in a college-level curriculum, and it's based on a course that he's been teaching for over 20 years. That was later then in 2008 turned into a teaching company lecture series on big history, which was extremely popular, and recently been noticed by the Gates Foundation and others. Techonomy conference, we'll be speaking in February 10th. So it seems like maybe the zeitgeist is right for some educational reform in core science curriculum, history curriculum. It's really exciting to see it get this attention. He spoke on Tuesday night at the New York Academy of Sciences. Yesterday he spoke at the National Science Foundation, and today he speaks at Villanova University. We're very pleased hosting here in Philadelphia. David Christian was born in 1946 in Brooklyn, New York. His mother's American, his father's English. He, however, grew up on the other side of the Atlantic, in Atlantic Ocean, in England and West Africa. And he went to Oxford University and eventually got a Doctor of Philosophy degree in Russian history at Oxford University, at which time he moved to Sydney, Australia, at Macquarie University, and where he has taught for a number of years, except for a brief sojourn, 8 years I believe it was, at San Diego State University. He's recently returned to Sydney, Australia, and continues to work in promoting big history, teaching as a visiting fellow at the University of Vermont, as well as University in Seoul, South Korea. The book has been translated now into Chinese and Spanish, and soon to be also Korean, and really provides what we often sometimes say at Metanaxis, the whole story of the whole cosmos of the whole person. And we live in a moment where there's enormous fragmentation of knowledge and exponential growth of knowledge, and now we really do have a map of time and a map of ourselves. And so you're in for a real treat today. Please help join me in welcoming David Christian.
Thank you very much, Billy. Billy has been a wonderful host very grateful to him, and I want to thank Villanova also, in particular Lowell Gustafsson, for inviting me. And I want to say how delighted I am to see my old friend and colleague Jeff Cowling, who Jeff actually taught with me 20 years ago when I first started teaching this course. That's a wonderful treat for me. I immediately have an apology. The slide gives away the fact that this is a lecture I gave very recently, and I'm afraid I didn't get around to adjusting the introduction, for which I apologize. I want to talk about science as a modern origin story. But let me begin by just describing my own background slightly. By the way, can you hear me at the back? If not, I'm very conscious of not having a microphone, so please tell me if you can't hear. I've taught big history courses for 20 years now. I started in 1989 at Macquarie University in Sydney. And what they do is they survey the entire past over 13.7 billion years. When I started out, it seemed a completely lunatic project. I have to say that it's getting a bit of purchase, which for me is very exciting. Historians look at me slightly less strangely than they did 20 years ago when I describe this now. Scientists go, duh, obvious, why not? So it's the historians I struggle with. The story I tell is based on modern scientific scholarship. I'm using the term scientific broadly to include, say, historical scholarship, scholarship based on evidence and using the most rigorous canons of modern academic research. Big history, teaching big history, because originally I'm a Russian historian, as William Grassi said. Big history changed how I think about the relationship between different types of knowledge, and in particular between modern science and ancient or traditional forms of knowledge. And the reason for this was that once I started trying to teach this with many other colleagues, and at first we really didn't know what we were doing. We just thought it would be exciting to try and tell the whole story. I realized, and I think we all realized teaching this, that what we were doing was teaching a modern origin story or creation myth, and I'll use those phrases quite interchangeably. And this raised a problem. If I'm teaching a modern origin story, then as a teacher, I have to try to help my students understand what their relationship to it should be. Above all, should I make the claim that this story is true and all the others are nonsense? Now, I was very reluctant to make that claim. First, because I didn't believe it was true. But secondly, it just didn't sound right anyway. So I had to work very hard to try to find a way of explaining the relationship between modern knowledge and traditional knowledge in a way that did respect to both types of knowledge, without falling into an extreme relativism, because I knew that many of my students would see two epistemological positions. One is, this is right, everything else is wrong. The other was, they're all just stories. So I had to try to maneuver them somewhere into the middle, to a subtler position in the middle. So exploring that question, I hope, will be fruitful in thinking about big history and science. Now, what I want to do in this lecture is, I'm going to begin the first part. I'm going to be looking at creation myths in general, and I'm going to be taking one example of a creation story, origin story. I define origin stories, or creation myths, as rich collections, they're never just single stories, rich collections of linked stories about how things came to be. I think a good metaphor is that of cosmic maps, which is why I called my book Maps of Time. But there's a great problem whenever we try to look at origin stories, and that's the problem of looking at them from inside or outside. They look very different depending on whether you're inside them or outside them. Their richness, their beauty, their power are very hard to see from outside, and we need to be really aware of this in looking at traditional myths. Here's a quotation that captures this from Encyclopedia Americana. A myth is understood in its own society as a true story, It's only when it's seen from outside its society that it has come to acquire the popular meaning of a story that is untrue. And the word myth in common usage, I think, captures that tension quite well. So here's an image. From outside, origin stories look, I think, a bit like pressed flowers. They may look exotic, they may look beautiful, they don't have life. Or here's another image, which I'd like you to keep in mind as we talk about them. Beetles pinned to a board, okay? Very beautiful, absolutely gorgeous, quite exotic. What we don't see is the life and what they do and their activity. And I hope this is a helpful image to carry in your mind as I look at a story. Now, one more warning before we look at this. What we're going to look at is filtered multiply. So to treat it, to give it justice, we need to be aware of all the filters between us and the story. So I want to describe them so you're aware of them. This comes from some extracts in an anthology of origin stories by Barbara Sproul called Primal Myths. It's a wonderful introduction to origin stories. The extracts are from work by a French anthropologist, Marcel Griaule. And what he's doing is recounting conversations with Ogotomeli, who is we can call him a wise man of the Dogon people of Mali. Okay? Now, we also know that Ogotomeli himself is editing this story. You'll see in the extracts I show very clear evidence that Ogotomeli is thinking, how much do I tell this anthropologist and how do I phrase it? And finally, it's also translated into English, one more filter, and finally, it's edited by me for the PowerPoint. So remember all of those filters. We need to make a real effort to see this story live, in context. Now, I hope you can see, this is a slide that, yes, okay, I think you can see well. So, let me go through this story. I've got about 5 slides that take us through the story. Part 1, stars and the solar system. The stars came from pellets of Earth, flung out into space by the god Amma, the one god. He had created the sun and the moon by a more complicated process, which is the first attested invention of God, the art of pottery. The sun is, in a sense, a pot raised to white heat and surrounded by a spiral of red copper with 8 turns. The moon is in the same shape, but its copper is white. It was, so I can read it easier here actually, it was heated only 1/4 at a time. Ogotomeli was anxious, and this is the reminder that it's Griaule who's talking to us here. Ogotomeli was anxious to give an idea of the size of the sun. Some, he said, think it is as large as this encampment, which would mean 30 cubits, but it's really big. Its surface area is bigger than the whole of Sangha Canton. And after some hesitation, he added, it's perhaps even bigger than that. Okay? That's the stars of the solar system. Part 2, oh, this is, okay, forgive me, I'm gonna just, oh, no, I normally use a Mac, and, okay, you could, okay.
That's perfect.
We need part 2. I apologize for this. Here we are, part 2, but part 2 is...
Just do both.
Arrange, send back. Is that better?
Yes.
Okay, my apologies for that. Okay, part 2. Just blank out the last 2 minutes. Okay, the god Amma, this is Amma creates the earth. The god Amma took a lump of clay, squeezed it in his hand, and flung it from him, as he had done with the stars. The clay spread and fell on the north, which is the top. I think he's thinking of a potter, flinging some clay down before using a wheel, maybe. And from there stretched out to the south, which is the bottom of the world. The Earth extends east and west with separate members like a fetus in the womb. It is a body, that is to say a thing with members branching out from a central mass. This body, lying flat, face upwards in a line from north to south, is feminine. Its sexual organ is an anthill, and its clitoris a termite hill. Amma, being lonely and desirous of intercourse with this creature, approached it. That was the first occasion of the first breach of the order of the universe. The story is beginning to get complicated. Part 3, diversification, complexity, and trouble. Marketability ceased speaking. He had reached the point of the origin of troubles and of the primordial blunder of God. And he says, if they overheard me, I should be fined an ox. This is a reminder of Marketability censoring the story. We can be pretty sure that as he says that, he's thinking, how much do I tell, how much do I not tell to agree on? At God's approach, the termite hill rose up, barring the passage and displaying its masculinity. It was as strong as the organ of the stranger, and intercourse could not take place. But God is all-powerful. He cut down the termite hill and had intercourse with the excised earth. But the original incident was destined to affect the course of things forever. From this defective union there was born, instead of the intended twins, a single being, the Thos Aureus, or jackal, symbol of the difficulties of God. Part 4, life and the Nummo twins. God had further intercourse with his earth wife, and this time without mishaps of any kind. Water, which is the divine seed, was thus able to enter the womb of the earth, and the normal reproductive cycle resulted in the birth of twins. And these twins are wonderful, as we'll see. Two beings were formed. They were green in colour, half human beings and half serpents. From the head to the loins they were human. Below that they were serpents. Their red eyes were wide open like human eyes, and their tongues were forked like the tongues of reptiles. Their arms were flexible and without joints. When I read that, I think of Harry Potter. You know, when Harry Potter's cured at one point, he's got no bones left in his arms. Their bodies were green and sleek all over, shining like the surface of water, and covered with short green hairs, a presage of vegetation and germination. These figures were the Nummo twins, water gods who later play a crucial role in the creation of the earth. And here's the last slide that I'm going to give in these extracts. Remember, this is part of a huge cycle of stories. Humans, African and European. He said that while Africans were creatures of light emanating from the fullness of the sun, Europeans were creatures of the moonlight, hence their immature appearance. Now, remember the image of a beetle pin. That's all I can give you in trying to give you a sense of the story. So now I'd like to just make some generalizations about it. There are many things you could say, so I'm just picking a few things, some striking features. First, it's universal. The suite of stories embraces all origins. This is very powerful if you think about this. Most stories start in a place that's already given and go somewhere. An origin story tries to tell the whole damn thing. So it's got meaning in a way that smaller stories don't. If there's no meaning in this story, there's no meaning everywhere. So being universal is powerful. Secondly, I don't know how many of you picked this up, but there's a problem at the beginning of an origin story. In a normal story, you've got a world, you've got people, you've got animals, and you just say, and you just start, okay? With an origin story, you have nothing, zero. So how do you start? And it turns out this is an insolvable paradox. So what does Marketability do? Well, cuts the Gordian knot. He simply says, there was a God. Okay, forget it. Don't ask any more questions. A God is posited without explanation. This is kind of logical bootstrapping. And if you think about it, you'll realize many origin stories do exactly that. Third, There's a theme of increasing complexity. The world begins simple, but it gets more complicated. Division, diversity, complexity, and the growing cast of characters and objects. And those objects have new properties. So new qualities and properties enter the story. And fourth, well, let's be frank, it's absurd. From outside to us, this is an absurd story. It's illogical, it may be exotic, it may be fun, it's lifeless, it's powerless, in the sense that I don't think anyone in this room is going to be so moved by that story that it's going to change your ethical thinking or how you think about the world. It's powerless. Now I'd like to try and look at it more sympathetically and say some things that might be true when it's seen from inside. First of all, we can be very sure, and I think any anthropologists in the room, I hope, will agree with me, that from inside it was authoritative. I deliberately use the word authoritative. It has the feeling of truth. It feels like truth. Now, in this it's very similar to modern science. And some of the reasons are also similar. We often forget that traditional origin stories contain a huge amount of empirical information, much of which has been carefully tested. There is a sort of Popperian process of falsification that goes on behind much of the information in any origin story. So what they're doing is they're building on the best available knowledge of a given society. Let me develop this slightly further. When I say authoritative, one thing I mean is that for those for whom they are new, for young people, for example, being educated, the first reason for taking them seriously is that they're told by respected elders. The man on the right is a man called Burnham, who was an Aboriginal storyteller. And I got to know him. He was a wonderful man, and he died about 10 years ago. And the man below him, I don't think I need to introduce, okay? The stories, the information they give is tested empirically. Now, it may come as a surprise to think of this, but it is really true. Ogotomeli's story, for example, it lists important animals. There's law about procreation and sexuality. There are details of major farmed grains. There are symbolic accounts of human anatomy and the world's geography. And this is all information that we can be sure was tested in that society. So the point is that when we see origin stories, we normally see them with the boring bits left out. And for a modern anthologist, the boring bits often include the long lists of bits and pieces that contained empirical information about that society. So first, they're authoritative. They have the feeling of truth. Secondly, it's wrong to assume that they were treated too literally by the people who told them and heard them. We often make this assumption, but in fact all origin stories are paradoxical and metaphorical, not because the people who told them were naive, but because the things they're saying are very complicated. Let me just illustrate what I mean by this. And this comes again from Briol. Briol once asked Ogotomeli about a curious detail in a story in which many creatures stood on a step 1 cubit deep and 1 cubit high. And Briol says, how is that possible? And here's Ogotomeli's wonderful answer. And as he gives it, you can almost hear the weariness. He's been asked this so many times, and there are many teachers in this room. This may be familiar to you. All this had to be said in words, says Ogotomeli, but everything on the steps is a symbol. Symbolic antelopes, symbolic vultures, symbolic hyenas. Any number of symbols could find room on a 1 cubit step. Ogotomeli is not telling this story naively. He's telling it with great sort of literary and philosophical sophistication. And Briol adds that the word he translates as symbol literally meant word of this lower world. And the third thing is these stories are powerful from inside. They frame knowledge and they steer behavior. They provide believable descriptions of the universe that shape behavior. They're rich, living, credible, inspiring cosmic maps. Barbara Sproul writes of them. Creation myths are the most comprehensive of mythic statements, addressing themselves to the widest range of questions of meaning. But they are also the most profound. They deal with first causes, the essences of what their cultures perceive reality to be. In them, people set forth their primary understanding of man and the world, time and space. Okay, now before I go on to a modern creation story, here's one more familiar example. Christian cosmology linked to the Ptolemaic vision of the universe. Here's us at the center, and God is outside, a system of circles and spheres which carry the heavenly bodies. Now, this too is universal. It's a total map. From outside, it's absurd. It's crazy. For some modern scientists, it's just absurd. It raises the problem of beginnings. And for this story, the problem appears whenever a smart aleck kid says, yeah, okay, but who made God? That's the paradox of beginnings. It's a story of increasing complexity. It's authoritative, based on trusted sources and significant empirical evidence, observational evidence in the case of the cosmology. It's open to some revision. It's not completely fixed. And it's powerful. It framed ideas of the universe and right behavior in the Christian world for almost 2,000 years. Okay, that's a traditional story, and I hope I've established some parameters for thinking about origin stories. Now, I'm going to tell the modern story. Now, I normally take 13 weeks, 26 lectures to do this, and in the teaching company courses, I have 48 half-hour lectures. So I'm going to talk incredibly fast. Okay? Now, what I'm actually going to do is present a version that's like the pinned Beatles. Okay? It's extracts. And to be fair, to make the comparison fair. Big history courses are modern origin stories, so this is highly compressed, it's non-technical, and it's extracts from a modern origin story. So, seek notes, please. Okay, so here we go. Part 1, the origin. In the beginning, 13.7 billion years ago. Now, forgive me, but I think I need to stop immediately. And we need to talk about what 13.7 billion years mean. Okay, so what does a billion mean? Our minds, frankly, are not designed by natural selection to deal with a billion years mean. Here's a quick and dirty answer to that question. Count 1 and 2 and 3 and 4 and count up to 1 million. It's going to take you 11.5 days, okay? Now let's do the same thing, but let's count up to 1 billion. And this is going to be a reminder that 1 billion is not just more than 1 million. It's 1,000 times 1 million. So I don't know if anyone wants to try and guess how long it would take. I just got out the calculator and did this. But I'll give you the answer. It's 32 years to count to 1 billion. And we're talking about 13.7 billion years. So this is a reminder of the scale of the story. It's not, by the way, the largest cosmological story. Buddhist cosmologies imply timescales vastly, vastly greater than the modern origin story. Okay, back to the beginning. 13.7 billion years ago. We don't even know if time or space existed. In fact, we don't even know if nothing existed. Let's be frank, there's nothing we can say, okay? This is a bit like a sort of primordial chaos, but even that's just words, really. Then, something happened. Something appeared out of the whatever it was there was or wasn't before. But we can say certain things about that thing. It was tiny. Think atomic particles or subatomic particles. That's the right scale, okay? It was incredibly hot. Gazillions, that's not a technical term, but gazillions of degrees centigrade. And no wonder, it contained all the energy and all the matter of the entire universe. So of course it was hot. You cram it into that small space. And it's also expanding very fast. And again, this is intuitively right, if you think about it. Crush all the matter of the universe into a space the size of an atom, and it's going to be busted. Okay, so it's going to be expanding very fast. Okay, so it's expanding. Like an explosion, which is why we call it metaphorically, the Big Bang. Now, in the first second or two, the rate of expansion slowed. Now, I'm going to gallop through this. Please don't worry about the technical details. I'm giving a very non-technical version of this. Just get a sense of the impression if this is not a familiar story to you. The rate of expansion slowed. At billions of degrees, matter and energy were interchangeable. This is what Einstein showed early in the 20th century, and that's what his famous equation points to. Then, slowly, they begin to sort of separate. Energy begins to stabilize in several main types, and they include gravity, and also something that we call anti-gravity or dark energy. Whenever you see a cosmologist use the word dark, you know that they don't know what they're talking about. They're saying, we don't know what this is, and that's what dark energy is. Secondly, electromagnetic radiation, which includes light, and at least two other forms which I won't talk about. Matter too began to stabilize, and we can think of two main types. First, dark matter. Once again, that's cosmologists' code for we don't know what it is, although there are high hopes that we may be able to identify it fairly soon. And secondly, what I'll call atomic matter. That's what we're made of: quarks, electrons, protons, and so on. Atomic matter is much more interesting than dark matter. It seems to be able to do things, to create things. So atomic matter is going to loom large in our story, and so is gravity and electromagnetic radiation. Then, also in the first second, most atomic matter disappeared as matter and antimatter destroyed each other, turning back to energy. Don't worry too much about this. If this idea is not familiar, just get a sense of the craziness of the story. After a few seconds, expansion slowed. Temperatures dropped to just a few million degrees. That's about the temperature at the center of the sun. And the universe is a hot plasma. That is to say, we have naked protons and electrons with their with electric charges. So the whole universe is electrically charged. This is like the center of the sun. And energy and matter are still entangled. Those charges, as it were, catch photons of light. Then, after about 380,000 years, there's a phase change. Now, I'm going to come back to the idea of phase changes. This is an idea that will crop up many times in the modern story. A phase change is when a tiny change leads to huge qualitative differences. So think of steam and water. Think of steam, it's 150 degrees. We cool it to 130. Not much happens, it's a bit cooler. We cool it to 110. Not much happens, it's a bit cooler. We cool it to 90 degrees centigrade. Bang! Something happens. The steam turns into water. That's a phase change. And this story is full of phase changes, and they play a very important role in it. So here's one. Temperatures fall until protons could capture electrons to form atoms that were electrically neutral. The result is that the whole material universe, which has been crackling with electrical energy, suddenly goes neutral, and now photons of light can flow freely through the universe. And that release of energy we can see today, and we call it the cosmic background radiation. It's one of the central ideas in modern cosmology. Okay, that's the first part of the story. Now, some brief comments. Well, it's pretty bizarre. I mean, in some ways, frankly, seen from outside, as bizarre as Marketability's story, I think, in many ways. And I've left out, by the way, some of the strangest features, such as inflation. It's a very strange story. But it's based on so much well-tested evidence that most cosmologists believe that something like this actually happened. In other words, for modern scientists, this has the feeling of truth. Okay, part two, increasing complexity and diversity. Now this is going to be a central theme, and we saw this was a theme in Marketability's story. New things appear, the universe gets more diverse. The universe began quite simple in a sense. At the time we left off the story, in the universe there were huge clouds of hydrogen and helium atoms. You may remember hydrogen is the simplest element, helium is the next simplest, just 2 protons in its center. There's the cosmic background radiation, there's dark energy, and there's dark matter, not much else. Think of what's not there. No galaxies, stars, no heavy chemical elements, no gold, no carbon, no nitrogen, no oxygen, no planets, no living organisms, no human societies. So this is what I mean by saying it begins simple. Then, over 13.7 billion years, more complex things appear. Now, let's be precise about this. Imagine I were to pick you up and hurl you randomly somewhere in the universe and ask you to reach out and grab a sample of what was around you. I can almost guarantee that what you'll grab will be almost near absolute zero, and it will be vacuum. It'll be incredibly simple. It will not be complex. So most of the universe today is still very simple. But in little pockets, particularly around stars, new and more complex things have emerged, and that includes us. So what is complexity? Complexity is complex. I hate to say that, it really is complex. So what I'm going to do is give a quick and dirty definition of what I mean. Complex things have many components. They're diverse and they're varied. Second, those components are linked in a very precisely arranged structure. Think of a Boeing 747. Think of all the bits of a Boeing 747 just scattered in a junkyard. This is an image that Fred Hoyle used to use. Now, put them together in a precise pattern, and you suddenly have something very different. You have something complex. There are new energy flows. Fourth, new emergent properties. Take the bits of the 747, put them together correctly, and suddenly you don't have just lots of bits of metal and plastic and wires and so on. You have something that can carry you and me for thousands of miles through the air. It's got new emergent properties. And finally, it dies. When the energy flows cease, when the music ends, the structure falls apart into its simple components. So this is complexity. And our story is one of increasing complexity in tiny pockets of the universe. So I want to tell the first part of that story, which is the creation of stars. Stars are formed as gravity magnifies tiny variations in temperature and density. Let me try and explain that for those of you who aren't familiar with the story. This map is a map of the cosmic background radiation. But what it does is it picks out hotter regions, such as those red regions, and slightly cooler regions. Now, the differences are absolutely tiny. But the point is that there are differences in temperature and density. Now, gravity gets stronger if there's more stuff, more mass. So what we know is that in these areas, the force of gravity is slightly more powerful. So what it's going to do is it's going to clump those areas together. So wherever there's increasing density, they're going to start clumping together. Now this is a repeating pattern. Even dark matter is clumped by gravity. So what this shows is dark matter out here, and embedded in it, little clumps of atomic matter. Now, how do stars form? Think of these clouds of matter, billions of them, slowly collapsing under gravity. As they collapse, gravity gets stronger. The collapse continues, it speeds up. Dense regions collapse even faster. As they collapse, they get hotter. Temperatures rise. Hydrogen atoms get more and more energetic. They collide more often until finally a threshold is crossed and we have phase change. And what happens at that threshold is this. Temperatures at the center reach 10 million degrees. Hydrogen nuclei, protons, fuse together to form helium. And as they do so, there's a huge release of energy. And that stops the star collapsing. So it creates a stable object. And this object is now emitting energy into surrounding space. And that is what a star is. They represent a new level of complexity, new structures, new emergent properties. There's fusion in the core, heat from the center travels out, new supplies of hydrogen here. You can see the structure very clearly. And heat at light is pumped into the cold vacuum, or near vacuum of surrounding space. And that energy flow is what keeps everything going on our planet. That's our battery. Stars are still forming today. If you go on the Hubble website, you can see lots of very beautiful pictures of areas of star formation. Okay, that's an example of a threshold of increasing complexity. Now I'm going to cut out huge parts of the story, okay? But I'll just tell you what I'm cutting out. We see new levels of complexity appearing as tiny incremental changes create new entities with new emergent properties. And these in turn allow the building of further forms of complexity. And here are some major thresholds. In dying stars, new chemical elements are formed. Carbon, nitrogen, oxygen, iron, uranium. So gradually, in areas near stars, within galaxies, you get a chemically richer universe. And we can have chemistry, and we can have new types of materials. Those new types of material allow the creation of planets around stars. Planets are much more chemically complex than stars. On some planets, well, we know at least one, but I think the betting is getting better and better and better. There are lots of planets like Earth. In fact, just a week or two ago, I saw on a website that they've identified a planet quite near to us, which is just slightly bigger than our own, and almost certainly in a zone where there is liquid water. Okay? So probably on a lot of planets, life appears. Then life evolves. Eventually, it ceases to be just single cells, becomes multicellular, and we pick the story now up on Earth about 100 million years ago. Is Earth 65 million years ago at the end of the Cretaceous? This is a world ruled by dinosaurs. I wish I had a sound effect here because I've got a fabulous drum roll which would have woken you up at this point. Okay, so this is a world of dinosaurs. Okay? And there was another drum roll here, which you're just going to have to imagine. 65 million years ago, a meteorite landed off the Mexican coast. Its impact was like that of a nuclear war, and the result was that most species of dinosaurs, probably all, I should say, went extinct. And in their place, mammals flourished. Before this, mammals seemed to have been, for the most part, tiny, insectivorous, burrowing animals. Think tree shrews or something like that. That's where our ancestors were 65 million years ago. With the dinosaurs out of the way, they can sort of come out and start strutting around, and they can evolve and fit the new niches that are now open. So we are products of this mammalian radiation. This part of the story is worth thinking about for a moment. If that asteroid had been on a trajectory 5 minutes earlier or 5 minutes later, it would have missed the Earth. The dinosaurs would still rule the planet, and we would not be here. So don't think of this as a deterministic story. This is a story full of contingency. So we're products of this mammalian radiation. Bonobo chimps are very, very close relatives. You'll all know this. This figure's become a kind of iconic statistic. We share over 98% of our genes. So these creatures are very intelligent. They have rich emotional lives. They're socially intelligent. They're creative. They have language. These are fabulous creatures, and we're very, very close to them. So now part 3, humans. How do humans appear in the story? Oddly, this is a story that is still being put together. And one of the reasons it's still being put together is to tell it properly, you need storytellers from the sciences and the humanities. And they so rarely get together that this story is only now being put together. But I think we're very close to a decent answer. And I'm going to tell you what I think it is. Our species appeared approximately 100,000 years ago in Africa. It's equivalent. It could have been 60. Some say 60,000, some say 200,000, but let's say 100,000. I'm going to argue that our appearance marks a fundamental turning point in the history of Earth. This is a major, major new chapter in the origin story. So let me explain this. What makes humans different? What makes us so different from all other animals? Because in some ways we're very, very close to it. Okay, here's, and I'm going to gallop through this argument. I'm prepared to develop it more later on. All other animals, bacterial or multicelled, have static technologies. Now, by that I mean they evolve, they have a certain number of ways of extracting resources from the environment. But that repertoire has limits. It can expand slightly and contract slightly, but it has limits. And what that means is there's a limit to the range of the animal, the number of environments it can occupy, and its population size. And their behaviors don't change radically over long periods of time. Humans have dynamic technologies. Put slightly differently, we keep inventing new ways of relating to our environment, of getting resources from the environment. Now that's very powerful. It means there are no obvious limits to our range and population size. And so our behaviors change over time. Now again, this may seem very simple, but it's very powerful. This explains why we have a history and chimps don't. I don't know if this may sound an absurd question, but has anyone heard of a Department of Chimp History? And the answer, of course, is no. But the question why is worth thinking about. And this is why. Chimp technologies don't change, so they don't really have a history. Ours do, so we have a history. So why does this matter so much? Why am I making this huge claim that this is an event significant on a scale of 3.5 billion years? If a species' technologies improve from generation to generation, it will slowly control more and more resources. And we can predict certain things that will happen over time. Its range will slowly increase. Its populations will slowly increase. Eventually, dense, socially complex communities will appear. And eventually, it will control so much of the resources of the planet that other species will start to suffer. Is this familiar? We're the only species of which we know this is true. And the story is not modern. It didn't begin with the Industrial Revolution. It goes back to the beginning of our species. Here's the range of chimps. We have no evidence that it's changed significantly in the last 1,000,000 years. Here's where humans appear. We get tentative evidence as early as 100,000 years ago of them migrating within Africa. By 60,000 years ago, evidence of them migrating into Eurasia. That's not that significant. Many animals have made similar migrations because they're staying within similar environments. Now here's the first really significant migration. And I'm saying this not just because I live in Australia. But the reason I say that is because no other mammal made this migration. And to do this, you needed significant seagoing technologies, and you needed to be able to deal with an entirely new suite of animals and plants. So this looks like a line on the graph. What we're talking about is fabulous technological innovation. Here's a second migration worth thinking about. That migration, those two arrows, represent migrations into Ice Age Russia. Not just Russia, Ice Age Russia. So imagine yourself picked up and dropped into Ice Age Russia. How well you've been fared. And just think of the technologies you need. They all had to be developed. Technologies for using fire, for tailoring warm clothes, for building warm houses, and so on and so on. Each of these migrations represents great technological creativity. And by the end of the Paleolithic era, 10, 11,000 years ago, humans have spread to all parts of the Earth. And even in the Paleolithic, Our creativity means we're beginning to absorb more and more resources, and other species are suffering. This is a graphic of about 60 species of Australian megafauna that vanished pretty soon after humans arrived. There were kangaroos 12 foot tall. There were wombats the size of hippopotami. This would have looked like the South African savannah before humans appeared. We watched them. Now, if I'm right, the critical question, and it's a question that defines us as a species, is what's the source of this creativity? And I think there's an answer emerging from many disciplines. Language is the key. It's not that we have language and other species don't. To be precise, it's a threshold in the efficiency of language. Many species communicate, but not efficiently enough to preserve shared information over many generations. It's as if their communication systems are leaky. New ideas flow through the community, but then they flow out because the communication is fuzzy, it's garbled, it can't hold the information precisely. Homo sapiens crossed a threshold in linguistic efficiency, and this led to a phase change. Human language is so efficient that shared information can accumulate over many generations with no clear limit. And our capacity to learn from each other, instead of becoming sporadic, temporary, occasional, becomes permanent and sustained and cumulative. And that is a fundamental turning point in the threshold in the history of the planet. Let me give you an idea of the power of language. Again, this is a sort of cheap trick, but I'm going to just use, I'm going to say two words. And by doing them, I believe I can manipulate your brains very powerfully with just two words. This is something a chimp could not do. So here are the two words. Pink elephant. Now, I'm guessing that an image popped into your brain. Now, the really strange thing about that image is that I've never seen a pink elephant, you've never seen one, and you never will see a pink elephant. So I managed to put in your brain, from my brain, something that's never existed and that never will. That is just a quick illustration of the power of human language. And this is something we can be pretty sure chimps can't do. So populations grow. They grow very slowly in the Paleolithic, much faster in the Agrarian, then terrifyingly fast in the last 200 years. And we control more and more energy. Now here's an estimate of how much we control today. If this estimate's right, on average, every modern human is controlling the allocation of about 100 times the energy we need to survive. No other species has ever done that. Other species control just what they need. I mean, even T-Rex control just what they need in their time. We control astonishing amounts of energy. What sort of species can do this to a planet? This is a huge increase in complexity. Each brain has maybe 100 trillion neurons, and each of them is connected to thousands of others, and they're computing in parallel. Modern human society consists of 7 billion human brains, multiply connected through language, phones, and the internet, and computing in parallel. This is a level of complexity we've never seen before in the story. We don't know if it exists anywhere else in the universe. So where's it all going? Optimists see this focus on the creativity, our astonishing creative power, and say, we'll fix it, we'll sort it out. Pessimists fear that the amount of energy we now control, the extent to which we're messing with the biosphere, means we don't really know what we're doing. And we're going to mess up some very fundamental foundations for our existence. Okay, now, I'm just about at the end. And what I want to do is go through the story and then think of some similarities and differences with Olga Tomelli's story. But let's just get the chronology first. Let's imagine the universe began not 13.7 billion years ago, but 13 years ago. I'm dividing by a billion because we can handle 13, we can't handle 13.7 billion. So I hope this will give you a sense of the ratios of different parts of the story. So if the universe began 13 years ago, the Earth would have existed for about 5 years. Large organisms with many cells for about 7 months. The asteroid that killed the dinosaurs would have landed. Anyone want to guess that? I've given you the absolute figures. Anyone want to shout out the guess? Doesn't matter if it's right. It's just to try and get your brain solved. 3 weeks. That's me in a calculator. Could be slightly more. Humans would have existed for 3 days. You can probably remember what you were doing 3 days ago. Our own species, hominins would have existed for 3 days. Homo sapiens would have existed for 53 minutes. Agricultural societies for 5 minutes. Civilizations, that's when my colleagues in world history start getting interested in this story, by the way. I hope by now you're persuaded. This is quite late in the story. 3 minutes. Modern industrial societies for 6 seconds. We're a very late afterthought in the story, but a very, very strange one indeed. And how similar to other stories? To Ogatonelli's story. It's a universal story. It has a problem with beginnings. I think most cosmologists, they love to speculate about what there was before the Big Bang, but if they're honest, they admit they don't know. They can't deal with it. There's a theme of increasing complexity in the story. And frankly, it's absurd from outside. This is the view of fundamentalist religion. It's the view of many traditional religions. From the inside, it's extremely authoritative. It has the feeling of truth. It's not to be taken absolutely literally. So one example is, there was no bang at the Big Bang. There are metaphorical elements, if you look forward in the story. And its power. It shapes the understanding of the global intelligence. Now, I've stressed the similarities. I want to end by going back to a more familiar treatment and stressing the differences. And here are 3 crucial differences. The first, and perhaps the most crucial, is its scale. Traditional origin stories were told within smallish or bounded communities, and they were tested within those communities. The modern origin story is global, and it's globally tested. If your experiment fails in Tokyo but works in New York, you're in big trouble. If your theology works in Rome but not in Delhi, you're probably okay. So science is global in a sense that many other traditions aren't. And it's tested with a rigor that is probably orders of magnitude greater than other stories. And that, I think, explains its power. Its power to enable us to manipulate things, to get things done. It's also globally accepted. It's the first global origin story. It has the feeling of truth for educated people throughout the world. So it's the scale, I suggest, that explains its astonishing power. Now, secondly, this is less obvious. It's poorly known. I said it was known perhaps by a global intelligentsia, but it's actually very poorly known more generally. Now, this is important because traditionally origin stories lay at the heart of education. In almost any human society we know. So to think of a society that does not teach its children and its young people its own origin story is bizarre. And personally, I'm inclined to think it's dangerous. A society that does not teach its story is failing its students and its people, very significantly. And that's why I believe so strongly in the importance of teaching this story. The result of not teaching it is that most students have a sense of knowledge as fragmented into bits and pieces that cannot yield a larger meaning about life. They have a lack of a clear understanding of their place in the universe. And that encourages a sense of humanity itself as being divine. Finally, traditional origin stories, almost all of them, generate ethical imperatives, ethical rules, moral rules. Can the modern origin story do this? Will it evolve over time in a way that means that it may not provide something as simple as the Ten Commandments, but the information it contains shapes our thinking about morality and ethics? You can already see the beginnings of this in debates about genetic technology and so on. I'm going to duck that question and simply leave it hanging in the air, because I really don't know the answer, but I think it's the answer that arises out of this comparison between modern scientific origin stories and traditional stories. So thank you very much for your attention.
I think we do have time for some questions, but before we do take time for questions, I think an announcement. We still need an institute, thanks to Warrenton Stories sponsoring reception. So, question?
Yes.
Speaking inside this origin story, is it possible that it could imply that life isn't really as alive as we believe, and that it's just a result of complexity of chemical and physical interactions?
I think, yeah, one of the ways of thinking about life within the story is as an emergent property. Now, that doesn't mean it's not real. Emergent properties are real. And same with consciousness. I mean, our internal psychic world, although one of the consequences of talking about collective learning is a reminder that our internal psychic world is vastly more collective than we normally think. So you can try the thought experiment of asking, if you look inside your brain and you had never had language and you had never talked to another human being, how much of the stuff that's there would still be there? No. So this is a reminder that even our internal psychic world that feels so private and individual is profoundly collective if you're a human being. It's much less so if you're a chimp, because we don't get into each other's heads in the same way. Anyway, so the quick answer, I think, is that it doesn't mean that life is not real. It means that it may be helpful to think of it as an emergent property of certain forms of complexity. Yes, yes.
Thank you very much. It's an interesting presentation. I think that it goes right to the heart of an interesting historical issue that you raised at the end with the question of whether or not this origin story is capable of creating ethical distinctions. I think it goes right to the philosophical questions of the is-ought question, the relationship between what is, which science is really good at, and what ought to be. And science, for the last 100 years, for certain, 110 years maybe, since the turn of the century, the 19th and the 20th century, what is largely hidden. First from Hume's analysis of is-ought, and then right out of Oxford, your alma mater, essentially put out the whole question of what's called, as you I'm sure are aware, the naturalistic fallacy. So the naturalistic fallacy, it seems to me, for 100 years, right where all this great story of science was being developed, all the science as an institution were, in essence, held back from making any kind of ethical distinctions, because that was not part of science. It was a fallacy. It really was. So the question that I have for you then is, what do you see on the horizon right now that's overcoming that distinction that that's been around very strongly for 100 years, in fact, influenced the entire history of science for the 20th century, for certain. I think every scientist who must have won a Nobel Prize certainly knew this as like their primer for what they could do. So they could bring in their own ethical distinctions, and that came from their religious and or secular backgrounds. And they had a choice, and that's what we have today.
I mean, I have lots of ideas about that. They put on an agenda all sorts of ethical questions, many of which didn't exist before. So that's the first answer, is that we can be very sure that science, even whether it wants to or not, is already shaping moral thinking in very profound ways. Secondly, if I'm right, and I'm a bit tentative about this, but if I'm right that the major difference between the modern origin story and almost all traditional ones is that this is global, then it's as if the traditional, what it does very well is the information stuff. The traditional cultures, bound within certain traditions, did the ethical stuff so well. And I think partly the divorce is scale, but what we're seeing, I think, is as globalization becomes more powerful, an increasing argument between societies. Sometimes it looks like a violent conflict, but it's a discussion, and it includes ethical elements. So I think globalization is going to start affecting ethical discussions as well. But where it'll take us, I really don't know. So that's why my hunch is that science is going to be forced, like it or not, to move in this direction. How far, I don't know. Yes?
Yeah, I was
Two questions. Sorry, I was, this gentleman here and then this.
Two questions, maybe they're the same question. First of all, do you miss Dostoevsky?
Do I?
Do you miss Dostoevsky? And the second question is, do you conceive the big history that you're doing? Do you conceive it as a humanity, his history has ordinarily been conceived?
Do I miss Dostoevsky? I miss Russian history, and I feel that was a past life, and I rather regret that. I've been reading, now I read all sorts of nonsense, like cosmology and geology, and my Russian history colleagues think, where's he gone? Why isn't he reading the latest book on Putin or something like that? I'm not sure I understand your second question. What, is this a humanity? Is this a humanity?
We're talking in terms of things that are ordinarily understood traditionally as cosmology,
Yes.
ontology,
Yep, absolutely.
physics. You're not talking about, say, the Buddha
Right.
or Aristotle.
In a very naive way, I think what people who do this are trying, there are now quite a lot of people doing this, and as you may know, there's going to be a course in big history at Villanova starting next semester. What we're doing something very, very simple, I think. We're stringing together stories that already exist. The cosmologists tell a story, the planetary astronomers tell a story, the geologists tell a story, the biologists tell a story, the historians tell a story. I think the only original thing I've done is try to string them end to end and see if they stack up to a coherent story. And indeed they do. So yes, it's not in the humanities, it's not in the sciences. I see this as a way of solving C.P. Snow's great puzzle of the two cultures and of ending some rifts that have cut across modern knowledge. E.O. Wilson, in a book called Consilience, puts all of this very, very well. He argues that the discipline boundaries, and I've encountered them over and over with this course as sort of glass walls. They're hard to see until you crash into them. You use a word that works in one discipline but not in another, something like that. And E.O. Wilson argues, and I agree, there are huge intellectual synergies waiting for us if we can bring together ideas, concepts, information from cosmology and human history. And one of the clues for me is thinking about what it means to be human and asking if there is an answer to that question that's not metaphysical, that's not culture-bound, but that is scientific in this broad sense that I defined at the beginning. So I feel I'm trained in the humanities, but I've slipped my leash. Sorry, at the back, yes.
Yeah, you made the distinction between the previous origin stories and the modern ones, one between the global look. Isn't there another distinction, which is that the modern story does not posit a living originator, a god or some other biological entity that started it, Modern story, in fact, Hawking says that you don't need God in order for modern physics, according to the story. And I'm not familiar with all the origin stories, so could you tell me, do all the origin stories begin with either a God or some kind of being where life is not emergent, as in the case of the modern story, which you say, but is primary?
I'm not sure, again, I'm qualified to answer that, but so many possible answers spring to mind. I mean, one is the distinction is not quite as sharp as you may have drawn it. I mean, I think there are traditional creation stories in which there may be spirits here and there, but they're not the kind of foundation of the story. I mean, some versions of Buddhism, for example, come very close to just saying, look, the universe just is. Yes, there are gods, so they do things. Or you think of the Homeric story, the gods are there, but they're not necessarily founded. And the same with the modern story. Of course, there are many, many scientists who find this story either quite compatible with the idea of a sort of founding being, or they find that that idea is necessary to make the story complete. Maybe that's an aesthetic judgment. I don't feel the need for that, but I think many do. So the line between a modern story without God and earlier stories with gods may be not quite as sharp as you're suggesting, but I certainly agree. I certainly agree it's there. And one response I've heard to that question is that if you think of the evolution of knowledge, and I'd love to talk about Paleolithic science. I think Paleolithic knowledge was very good within its own parameters. You can say that the idea of God was a hypothesis. This is thinking Popperian terms. And it was a hypothesis that worked in many, many societies, but now we can explain so many of the things that hypothesis was used to explain without the hypothesis, that past use of the word God in some contexts is beginning to look like a kind of placeholder in traditional knowledge. So that's one possible answer. I'm not sure it's the best. Yes?
How does most origin stories, I think, deal with the issue of our contingency, deal with the issue of our finitude? We would all agree that none of us are going to get out of this life alive. Could you speak to how this story deals with what I think most origin stories deal with, if not all origin stories, namely our finitude? The fact that origin stories give meaning to life, but they also, I think, all of them give meaning to the fact that I'm not going to get out of this world alive. Could you speak to that?
I suggested in passing that the idea of complexity is looking like a central theme in the modern origin story. But one of the components of complexity I suggested is death. And as the modern story has evolved, we've become aware that more and more complex things do actually die. So the fact that things have beginnings and ends seems to be just part of the story. I don't think it can offer any consolation for that. I think at the moment, all it can offer is the statement. Things begin and they end.
It is what it is.
It is what it is. It is what it is. Yeah, yeah. And that itself, incidentally, may provide a very powerful foundation for a lot of ethical things. It's often thought that it can't, but it may.
And on that note, I'm looking at the time. I think I'm right. Probably need to stop and you thank Jeff for introducing his laptop. And there's a $100 bill up here for you, Jeff. And I'd like to remind you that there's a reception. We're talking, Father Fitzgerald, where's it going to be? Right outside. Very good. Let's thank David Christian.